Hello guys, welcome to Introduction to Work Energy and Power. If you want to get 100% in work energy and power, you can enroll into my program for just 20 Rand. You're gonna enroll into this program, get 100% in work energy and power today for just 20 Rand. So if you want to enroll, you're just going to text me and I'll be on your way. So let's actually check up the basic introduction for work energy and power and a couple of things that you should know. The first thing that you should know is work energy and power covers three main things. Number one, it covers the work done, right? It covers the work done. Number two, it covers the mechanical energy. It covers mechanical energy. And number two, it covers the work done by non-consecutive forces. So let's actually, on this video, just focus on the work done, right? Let's focus on work done by certain forces. So what is work done? So work done by a certain force equals to that force time is change in x, that means the distance, the cos of theta. So F is actually the force, and then change in x is going to be the distance. Obviously in the x direction. If it was changing y, it would be the distance on the y direction, and the cos of theta means the what do you call the direction, right? So the theta actually means the direction. So let's actually say we want to calculate the work done by force applied. We're going to say force applied change in x, the cos of theta, right? Let's look at something extremely nice. I want to show you something very quick. Let's look at this. Let's say we are having this, right? And we know this is going to be 0 degrees. This is going to be 90 degrees. This is going to be 180 degrees. And this is going to be at 270 degrees, right? So if we want to focus on work net is given by the formula. Work net equals to change in kinetic energy. So the work net, it is the sum of all the forces. So let's say we're actually having a block. So we know that in a block, we're going to have the work done by force applied, plus the work done by the friction, plus the work done by normal force, plus the work done, normal force, right? Plus the work done by gravity. That's almost everything, and it's going to equals to change in kinetic energy, right? And we all know that kinetic energy or change in kinetic energy is going to be 1 over 2m V final squared minus V initial squared. Well, let's actually look at work done by force applied. Let's actually look at work done by force applied on this problem. So let's say we are having a block, right? We are having this wonderful block. It is actually moving on this direction with force applied that equals to 50 newtons, right? And then this thing is actually 3 kg. And we're having frictional force that equals to 30 newtons, right? So let's actually try to find the work done by force applied. So let's say we want to find the work done by force applied. It is going to be force applied change in x, the cos of theta. So let's say this block actually moved from point A to point B, traveling a distance of at least 5 meters. So we know that the work done by force applied, not just force applied, the work done by force applied, it is going to be the force applied, which is 50 newtons. And then I'm going to multiply this with the displacement, that is 5, the cos. What about theta? Which angle do we actually use? So if you check this Cartesian plane, based on the direction of the block, we're gonna determine which angle to use. So the force applied is actually on the direction of motion, right? So the direction of motion is going to be 0 degrees. If you actually compare this, moving on this direction, it is also going to be 0 degrees, right? So it's going to be 0 degrees. So you're going to say, well, it means we are going to have 50 times 5. Cos of 0 degrees, it's the same as 1. So that's actually your answer. And this thing is actually measured in joules, all right? Let's say now we want to calculate the work done by frictional force. So we're going to say the work done by frictional force, it's going to be frictional force changing x the cos of theta. So you're going to say, well, frictional force on this question, it is actually 30 newtons, right? So you're going to say, well, 30 newtons, and then you're going to times it with the displacement, that is actually 5, and you're going to times this by 5, and you times this by the cos. But which angle are we going to use? So remember, frictional force acts on the opposite direction. So also 180 degrees, it's actually on the opposite direction. So you're going to say this is the cos of 180 degrees. So it means you're going to have 30 times 5 times a cos of 180 is the same as minus 1. This is the reason that on Newton's laws of motion, you know that if you are given F net, you know that the force applied will be positive and the frictional force will be a negative. This is where that negative is actually coming from. Let's say we want to calculate the work done by the normal force. We know that the work done by the normal force, we know that normal force equals to mg, right? So we're going to say, well, the normal force equals to changing x, the cos of theta. So instead of writing Fn, we do have the right to write mg, changing x, the cos of theta. So the mass of the block is actually 3. So I'm going to write 3, and g, it's 9.8, and changing x is going to be 5, the cos. But what is theta? So we all know that normal force is actually acting perpendicular to the surface. So it's going to be the cos of 90 degrees. So it means that here you're going to put 90 degrees. Well, we all know that 90 degrees is the same as 0. So you're going to multiply all these things by 0. And the work done by normal force is going to be 0 joules. That is why in Newton's laws of motion, we never bother to add the force of normal force, because it is actually 0, and this is where it is actually coming from. Let's say we want to calculate the work done by the gravitational force. It's going to be Fg changing x, the cos of theta. It looks similar to this, right? And we know it's going to have a mass of 3 times 9.8 times 5, the cos of 270 degrees. It is going to be 270 degrees, and 270 degrees, it's actually 0. So we're going to multiply all these things by 0. That is why we never bother to say force applied minus friction plus normal force. We don't bother it. Also, that is why we don't bother adding the force of gravity, because it is actually doing a work of 0 joules. So if we are given a problem, right? Let's say we want to solve a quick problem. Let's say we want to solve a very quick problem, and we're actually given this a problem like this. We're having this block of 3 kg with force applied of 7 newtons, and also with frictional force of 4 newtons. And this block is actually moving from point A to point B. Let's say in point A, it is having a velocity of 3 meters per second, and we don't know the velocity here, and it covers a distance of 10 meters. And the question say, find the final velocity here. How are you going to do it? Well, you're going to say, well, the work net actually equals to 1 over 2m v final squared minus v initial squared. From the previous video, we know that we're only going to focus on the work done by force applied plus the work done by friction. That equals to 1 over 2m v final squared minus v initial squared. What is the work done by force applied? The work done by force applied is going to be 7 times 10, the cos of what? The cos of 0. And we know that 0 is going to be 1. Let's just say minus. Frictional force is going to be 4 times 10, the cos of 180 degrees. And that is why we're having this minus. Equals to 1 over 2. The mass is 3. We're looking for v final, isn't it? We're looking for v final squared. And v initial squared, we know it's going to be 3 squared. So let's actually hit this inside the calculator. I know I'm going to have 3 over 2 equals to V final squared minus 9. So if I actually take my calculator and punch this, I'm now going to have 7 times 10 minus 4 times 10. That actually gives me 30. So if I divide both sides by 3 over 2, I'm going to have a value of 20, which equals to V squared minus 9. So I'm going to take this 9 to the other side. I'm going to have 29 equals to V squared. So the V final, it's going to be the root of 29. That equals to 5.38 meters per second. So that is just a quick introduction of WorkNet. If you want to understand the whole topic and get 100%, you can actually text me and we're gonna work it out. Otherwise, guys, enjoy the rest of your day.